Integral challenge 5. Create a differential equation and take the integral to find the final speed equation. Okay, in the practical problem, integral question is not given like a math exam. Okay, the math exam typically said, well, find the integral of certain function this way. Well, this is this is only for math class. In the physics, the integral is come from the differential equation, and differential equation is somewhat complicated, and you have to figure out how to do integral, and that's a skill you really need to do the physics. Okay, now question here is, the raindrop fall from sky and speed increase because of gm, but it doesn't increase to the infinity because there is an air resistance. Okay, and air resistance counteract, and that's like speed square with some coefficient. Okay, the coefficient is depend on materials, water or some metal piece or whatever. The feather has a big K coefficient, and metal ball is very small K. So it's because resistance increase, but speed increase too. So there is some terminal velocity it's beyond certain speed, it doesn't increase any more speed, which is, you can tell the acceleration will be 0 at that point. So keep it in mind, in the differential equation you create, you can set acceleration 0, and that's going to give terminal speed. Okay, so let's tackle this problem. We use this mb dv dx. This is different. Most of the physics maybe you learn mg is a force, but acceleration is m second derivative of dt square acceleration. But this formula is okay to use when you try to solve it for time domain. But when you try to solve distance domain, this is going to be the one. This is based on energy dx. Energy is mv square, so mv dv dx. So when you solve the problem with the geometric domain, not the time, so this is the Newton's equation, and the force is mg minus k v square. So this is the resistance. Okay, so set mg equals ka square, a is square root of mg over k, then we can make the equation clean. The question is how you take a derivatives. Okay, so when you look at this, this is not how to take an integral. This is not like integral question you are given in the math class. You have to figure out v, and x is here. So you put them all together on the v, okay, and x. So you have a two integral to take. So integrating the result, we get this equals k over m x plus c. So when it start, x is 0. When start dropping, this x is 0. The velocity was 0. Then we can determine this coefficient, the constant value after integration. Okay, so this is the equation. So this shows when it drop certain distance, which is x, then what the speed is. Okay, then the speed keep increasing. This is not gonna be v equals some kind of format. You can't express the result by this kind of nice mathematical format. This is the best we can do after taking this integration. Okay, so this happens often in the physics. The nature is more complex, more complicated than the math exam. You never get this format. Okay, I hope you enjoy listening to these videos, and please check other videos. We have a lot of good physics and math videos. If you like, click subscribe.